Good afternoon. Are all of you excited to be the first day at OCP? I see a lot of smiles. Wonderful. So my name is Sam Bhattarai. I work for KIOXIA. I'm a director of product management for the data center products. And I'm going to be talking about EDSFF, E1.S Form Factor products, and why that's the next best thing for data centers. Before I get started, I want to mention that I have some colleagues in the back there that have some raffle tickets. So after you're done with the presentation, please pick up those raffle tickets. There are Ruchira and a bunch of other people there. And you can walk to our booth on the back side, and there's quite a few nice prizes for you. Okay. 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 So before I get started with my presentation, I want to just talk a little bit about KIOXIA and who we are. For those of you that don't know KIOXIA, we've been around for quite a long time. We're the inventors of flash 36 years ago, I believe. And we're one of the world's largest manufacturers of flash-based SSD products. We've got a broad line of products, obviously catering to all of the OCP and more, and trusted by all of the enterprise customers, data center customers, hyperscalers, all over the map. So please go visit our booth. And with that, I'll get started with our presentation. So stepping back, I just want to start off with a lot of discussions you heard upstairs at the keynote about energy consumption, and want to kind of lay the picture about why the E1.S form factor is something that's really conducive for this time. So you can see in this slide that over the last few years, the amount of energy being consumed by the data center is increasing. So in 2018, we were consuming roughly 1.5% of total energy produced in the data centers. And it's going up to go up to 3% in 2030. So you might think that's not a big deal, that's not a big increase, but that's doubling in that short time span. And so what I want to present to you is with using E1.S form factor, which has taken a lot of these things into account, we want to try to tamp down this increase of power being consumed in the data centers. Right? And looking at it from a different perspective, from a financial perspective also, this is what I'm showing here is really the overall storage market growth. In 2023, you're seeing 247 billion being consumed total in all of storage. This includes obviously hard drives and SSDs and storage software. But a big chunk of that is obviously flash-based storage. And the key takeaway here I wanted you to live with is that it's growing. We're at a hockey stick point in the industry, and it's going to go up to 777 billion by 2030. So this huge growth also means that there's a lot of new expenditure going on into the data centers. And we really want to have an impact by using a very efficient product like E1.S when we design data centers going forward. Drilling down a little bit more, what I'm showing you now is not only the overall storage, but the SSD market growth in that same time frame. From 2023, roughly around $21 billion, going up to around $48 billion in 2027. Now, within that, I want you to focus in on the red portion, which is the key part that OCP and EDSFF E1.S really caters to. And the red portion really shows that this year, 2023, we're spending around $7.4 billion in data center and enterprise use case. And that's going to grow up to around $22 billion, $21+ billion in in the year 2027. Now, you can also see that the share of the overall SSD is increasing from roughly around 30% today to we're going to be around 40% by that time frame. So the other takeaway is that the data center hyperscale as well as other 10,000 other data centers share of the SSD space is growing. So that is another reason why EDSFF and the E1.S form factor is going to be an increasing share, but we want to increase that even more so that we can really get the benefits of that I'm going to talk about of this form factor in the industry. Okay, drilling down some more, let's talk about within the SSD space. I have left out the SAS and the legacy SATA and really looking at what is the projectile going forward for PCIe SSDs. And what I want to focus in on is the different form factors here that I'm showing you. Again, I'm using the red color to focus on the E1.S form factor. You can see that the E1.S form factor is growing pretty significantly already. This year, it's going to be around 14% if the projections are right, and it's going to continue on growing up to 32% in this time frame. So you might ask me, so Sam, looks like it's already on the growth curve. Why are we promoting more of it? And we think that this is on the low side. And what I'm here to communicate to you and hopefully convince you is that the E1.S form factor was originally developed, and a lot of thought process went into it from the hyperscale guys that were looking at how to make a SSD that was very efficient and create a workhorse. What we have found over time, and having a whole plethora of different form factors, that the E1.S form factor is not only beneficial, the benefits of it not only can be used by the hyperscale data center, but also the 10,000 other data centers that are using flash arrays in their data centers. So that's really the message I'm trying to communicate, and I'll get to that in the next couple slides. So let me get to that right away. So the E1.S benefits, what are they, right? And I'll talk about it. So optimized performance. Now notice, I did not say maximum performance. This is not the case where you're trying to get the peak performance all the time. This is for workloads that are workhorses, really are meant for very high performance, continual performance. It's designed for PCIe 5.0. The second bullet I have there is very key. It's able to be tuned for the right type of performance that the customer needs. The second one is power savings. Right? It's designed to support higher IOPS per watt, a key metric for this. You heard this in the keynotes upstairs this morning as well. Really looking at what are the features in the SSD that are used in a very high ratio, and not putting in the bells and whistles that are only used by 1% or a few percent of the customer base. Right? So that's how we achieve the higher IOPS per watts. Again, second bullet I've got here is able to tune the various parameters for power. And I'll show you that in the next couple slides, where I've got some customer profiles using this E1.S form factor, but in a variety of different ways. And so again, that point there. Cost saving, it's purpose built. We've taken a lot of things out of the E1.S form factor that are not used by the heavy workload customers. It's built on building blocks, offers flexibility for optimized TCO or OPEX, right, which is critical for this segment. Improved thermals. You'll see that we've got a variety of sizes in the E1.S form factor. So based on what your thermal needs are, you can optimize for that by using the right form factor. High density, again, because you can use it just as a bare PCB in the 5.9 inch all the way up to 9.5, 15, and 25. There's a whole variety of different form factors. So you can really get density as you need. And I'll talk about that in the next slide as well. And finally, one of the key nuggets that I want you to take away with is the flexibility of this E1.S form factor. It comes with the ability to take into account all of these other benefits that are there and being able to use it for your particular use case. But that's, I think, one of the hidden nuggets of E1.S that I hope to convince you about. So net of it is, what I want to say is really provides for a very high TCO solution, and really solving for very particular needs of the data center community. So now let me talk about the E1.S flexibility story, right? And I'm going to use the 4OU rack to make this use case. Okay, so you can, like I said before, you can use the 5.9 millimeter to create that 4OU rack, or you can do that with a 9.5 millimeter product, or a 15 millimeter product, and a 25 millimeter product. Today, KIOXIA offers 3 of these form factor in the market. Some are used by hyperscalers, some are used by the general market. But we'll complement that with more of that, like the 5.9. So let me step forward and talk about how different customers are using the same one PCBA that is the fundamental part of E1.S and optimizing it for their particular use case. So the first one I'm going to talk about is a customer that was very intent on getting maximum capacity or high density. This could be because they were in a very constrained space, or because they are in a very high cost space like San Francisco or Tokyo or things like that. So those customers that wanted high density in a very small floor space he wants to maximize this thing. So how did he achieve that, right? So his criteria was maximum capacity. His secondary criteria is that we also wanted to abide by was the power to the drive, and the performance was medium, right? And so the flexibility was in the airflow. So this customer was flexible in terms of being able to supply more airflow in this configuration. Naturally, with a high density product, you are limited in terms of how much performance you get, and depending on the performance, you have to have higher airflow. So that's customer number 1 portfolio. So let's talk about the second one. The second customer had a high performance requirement. So they wanted to achieve around 12 gigabits per second consistent throughput. They had some secondary constraints. Was the 20 watts. They did not have the power supply to provide more, and they wanted to limit their airflow at around 0.205 CFM. So their flexibility was how much capacity they could have in that same 4OU rack. And in this case, they ended up with around 1,100 terabytes, but that was sufficient for this customer. So let me step on and talk about the third customer that also wanted high performance, but their flexibility metrics were slightly different, right? They had a set amount of capacity they needed to have, and they were flexible in what type of, how much power was provided to the drive. So again, this was met by using the 15 millimeter configuration for this customer. And finally, another hyperscale use case where they were very focused on having minimum airflow in this customer's use case because of constraints that they had. And their secondary constraints were that they wanted a capacity that I'm showing there, and then they were not limited by the power to the drive, right? So their flexibility was in the performance. So what I just showed you is the flexibility of this E1.S form factor in being able to address a very high density focused customer, performance focused customer that had flexibility in capacity, another customer that was also performance focused but had flexibility in the power supply to the drive, and a fourth customer that had limited airflow that they wanted to optimize for, but were flexible on performance, right? So moving on, I want to show that this is not something new that KIOXIA came up with about the E1.S form factor. What I'm showing you here is something that Meta already used, where they showed the airflow versus form factor within a constrained airflow in their Yosemite YV 3.5 chassis. Right? So this was shown last year at FMS. And so what I wanted to share with you is this is not something that we came up with that is new. The hyperscalers have been using this for quite a while, and I wanted to communicate this and promote this to the larger data center community so that you can also take advantage of what it is. Another one is also talking about the E1.S flexibility. as you look at the bandwidth of the product, what I'm showing here, if you look at the chart on the right-hand side, you see that there's a constraint in how much you are able to send in the bandwidth as you get in the higher capacity. So the fact that E1.S form factor is a small form factor that can basically provide 2 E1.S in place of a U.2, for example, you can get a higher bandwidth from that perspective as well. Finally, I just wanted to show you another part of E1.S, that is basically the thermal efficiency. This was also mentioned in several keynotes today, that we measured the thermal profile of E1.S, comparing it to the U.2 form factor. And as you get more vertical and closer to the axis, you have a more perfect thermal efficiency. So what I want to leave you with is that if you look at it from a power saving perspective, increased performance perspective, from a cost perspective, optimized flexibility that I focused on and showed you how different customers are using the same E1.S in different ways, reduced floor space, and improved thermals, I would like you to consider the E1.S form factor when you think about designing your next data center needs. As I finish up, what I want to leave you with is this was the forecast from Forward Insights up to 2027, and based on the benefit that we see that E1.S provides, we're making from KIOXIA our own forecast in how we see the market going, and we're anticipating that as customers see the benefit of E1.S, that this will project even further, and E1.S will really take over from both the M.2 and the U.2 space in a lot of data centers that are focused on flash-centric arrays. So last slide for me is I just want to leave you with is that, takeaway is that both from a cost efficiency perspective, the density perspective, performance from a consistent throughput, power efficiency, thermal, as well as flexibility, that E1.S really is something that will provide a lot of benefit. And hopefully we can, if you go back to the first slide I started with, that the power envelope that the world is consuming from data centers will be tamped down. So thank you. Appreciate your